going to work with our slope equations. And again, these are all equations that you've seen before. Nothing really new here. You spent quite a bit of time on them in Algebra 1, so I'm going to go kind of quickly through it, but again, I will explain everything. If you need to listen to something twice, please rewind the podcast, pause it, take notes, do what you need to do to make sure you understand what's going on. 3 very important formulas we all got yesterday. The slope formula, y2 minus y1 over x2 minus x1. We'll use that. Slope-intercept form of the equation, y equals mx plus b. We talked briefly about this yesterday, but let's elaborate on it just a little bit more. M here, the m coefficient of x is the slope of the line. The b represents the y-intercept. And again, from a graphing standpoint, we're talking about y-intercept. If this is the graph of my line, the y-intercept is this point right here where it crosses the y-axis. So that's my point 0, b. That's what we're talking about. Y-intercept does come into play, especially when graphing. For most of our discussions, it's not going to be a big deal. We're going to be concerned mainly with the slope. Finally, the point slope form, which we talked about yesterday, is essentially a rearrangement of the slope formula. And it's very, very useful, especially when I know a point and a slope of a line, to get the equation very quickly. In fact, it's the one we're going to use almost all the time. We're going to use point slope form. So you'll want to know all 3 of these formulas, what the variables stand for, what's going on, where we plug numbers in. Remember, when point slope form, when we plug our numbers in here for the x2, x1, y1, and the slope. Those are the numbers we'll plug in. All right. Write the equation of a line passing to the point 2, 3, perpendicular to the line 2x plus y equals 2. 2 things we need to know to write the equation of a line. I need to know a point on that line and the slope of that line. Point is easy. It's given to us. There's the point. So immediately I know it's y minus 3 equals slope x minus 2. Now, I can put parentheses around the y minus 3 or not. It doesn't matter. I have to have the parentheses around the x minus 2 because we're going to distribute whatever value goes in here for the slope in just a minute. So I've got my point. I now need my slope. The line we're given is 2x plus y equals 2. The problem is I cannot read the slope when it's not in slope-intercept form. That equation is not in slope-intercept form, so I can't just directly read the slope of the line. I have to rearrange this into that y equals mx plus b form before I can read the slope. So I got to do a little bit of a manipulation of this equation to get it that way. Fortunately for us, it's a pretty easy manipulation. I'm going to get y equals negative 2x plus 2, so the slope of this line is negative 2 from right there. Now, for my slope over here, I want the perpendicular slope. So we got to go back and review. I want a perpendicular line. Perpendicular line doesn't mean same slope. It means change the sign and flip the fraction. So negative reciprocal slope of negative 2 would be positive 1/2. To finish my problem, I now distribute and combine terms. So y minus 3 is 1/2 x minus 1. And then add 3 to each side. I get y equals 1/2 x plus 2. That's the equation of my perpendicular line going through that particular point. Let's try another one. This time parallel and perpendicular. So we actually have 2 questions, A, parallel, and B, perpendicular. In both cases, we have the same point. And in this case, we're given the equation in slope-intercept form, so I pretty quickly find that this slope, since we can just read it right off the equation, the slope is 3 of that line. So I'm going to do 2 different equations. A, first is parallel. So y minus, I got to choose the y coordinate of my point. That's this 5 up here. equals slope. Slope is going to be parallel, so same slope, x minus the x-coordinate of that point, which is 1. So y minus 5 equals 3x minus 3. Add 5 to each side, and I get y equals 3x plus 2 for A. Sorry, I ran out of space there a little bit. I'll try to do better on B. For B, same setup. But now we're perpendicular, so instead of using the same slope, we're going to use a negative reciprocal slope, or negative 1/3. And y minus 5 equals negative 1/3 x plus 1/3. To add 5 to both sides. So y equals negative 1/3 x. Now, 5 and 1/3 is what we're going to come up with, but we don't really like mixed numbers anymore. So we're going to express it as a fraction. It's going to be 16/3. And if you don't know how your calculator does that for you, if you can't do that on your own, you don't know your calculator does it for you, please ask me. I'll quickly show you how to do that. Turn 5 and 1/3 into a mix, or into a fraction. We don't want to decimalize it. We just want to leave it as a fraction. That's fine. Number 5, how do we know lines x equals 4 and y equals 2 are perpendicular? Well, where x equals 4, what does that line look like? Coordinate plane, x equals 4. Well, this is my x-coordinate, or my x-axis. If x equals 4, here's the point where x equals 4, and every other point going straight up and down fits that category. So x equals 4 is a vertical line. Y equals 2, there's where y equals 2, and guess what? All the way across. So y equals 2 is a horizontal line, and vertical lines and horizontal lines are automatically perpendicular. That's part of our theorem. A vertical line is perpendicular to a horizontal line. Neither one has slope. Well, I shouldn't say that. Y equals 2 technically does have a slope. That's y equals 0x plus 2. The slope of this line, the horizontal line, is 0. The vertical line, x equals 4, does not fit into slope-intercept form. It's a special case, vertical line. Vertical lines have no slope. There's a difference between slope of 0 and no slope. Slope of 0 is horizontal. Slope of undefined or no slope is vertical. And those two are always perpendicular. Finally, find the distance from the point 1, 0 to the line y equals negative x plus 3. Well, distance from a point to a line. Remember, we talked about this a little bit yesterday. We have to do the perpendicular distance. So what I need, and this is actually a relatively complex problem. The coordinate plane is going to help me here quite a bit, is I need to know, I'm not going to use blue. Let me use a different color other than blue on this. Let's use green. Okay. I need to know several things. I need to know the equation of my green line, which is the perpendicular line. Once I know the equation of that line, I need to find where these two lines intersect exactly. Now, fortunately for us in our picture, we can tell where that point of intersection is pretty easily. And then finally, I'm going to have to use distance formula to calculate that distance. So this is a big multi-step problem. Now, in this particular case, the coordinate plane makes it very simple to figure out that I've got 1, 0, and 2, 1 are my points, and we can just go straight to the distance formula. But let's run you through it all mathematically. Okay? First off, I've got a point not on the line at 1, 0. My point is 1, 0, and I need to be perpendicular to this line. So, the equation of that green line, I'll do it in green, just to make it set up, be y minus 0 equals slope x minus 1. And now when I put the slope in here, the slope of this line is -1. So a perpendicular slope will be +1. And I get y equals x minus 1. Fantastic. All right, so now I've got my two equations. Y equals x minus 1 is my green line. My blue line is y equals -x plus 3. We need to solve these equations simultaneously. We need to find that point of intersection. Since they're both set equal to y, we just set them equal to each other. So x minus 1 equals -x plus 3. Solving this out, I add x to each side, add 1 to each side. I get 2x equals 4, so x is 2. Once I know the x-coordinate, I can find the y-coordinate by substituting into either equation. So y equals x minus 1. So y equals 1. So the point 2, 1 is my point of intersection, which we already got. But that's a process we'd have to go through if I couldn't see it completely on the coordinate plane. Finally, we need to find that distance. So I'm going to use distance from those 2 points. Distance formula. It's not going away anytime soon, so you better get used to it. The point is 1, 0 and 2, 1. So when I plug that in, that's -1 squared plus -1 squared, or 1 plus 1, which is the square root of 2. That is the distance from that point to that line. Those are pretty complicated problems when we come across them, especially if we have to do all this upfront work. If it's a nice drawing like this and we just have to do this very last segment, then it's not so challenging. But it incorporates the idea of perpendicular lines, and it's something we need to be prepared to do. Here's another one. Find the distance from the point 6,4 to the line y equals x plus 4. I think one of these problems is going to be enough, so I think we can probably just go ahead and get rid of the second one. So I'm going to go ahead and delete that so I have enough space to work, especially. There we go. This time I don't have a picture, so I'm going to have to do the math. Well, so there are 3 things I'm going to have to do. Step 1, okay, I need to find the equation of the line. Find equation of perpendicular line. In order to do that, I need to know the point and a slope. My point is 6,4. My slope of this line, so the perpendicular slope is going to be -1. And I plug that in my formula. Y minus 4 equals -1, x minus 6. So y minus 4 equals -x plus 6. Adding 4 to each side, I get y equals -x plus 10. So that's the equation of my perpendicular line. Step 2, find point of intersection. Now both equations are set as y equals -x minus or plus 10 and y equals x plus 4. So I'm going to take the two x expressions, -x plus 10 has to equal x plus 4. Combining terms, I get 2x equals 6, so x is 3. To find the y-coordinate of the point of intersection, I simply plug into either one of these 2 equations. I'm going to choose the top one, it's easier. Y equals 3 plus 4, x is now 3, we learned that. So y equals 7. So my point of intersection is at 3, 7. That's step 2. Step 3, find the distance between the 2 points. 6, 4, and 3, 7. So the x-coordinates are 6 and 3. The y-coordinates are 4 and 7. And we do our algebra. 6 minus 3 is 3. 3 squared is 9. 4 minus 7 is negative 3. Negative 3 squared is also 9. That's the square root of 18, which I can simplify into square root of 9, square root of 2, or 3 root 2 is the exact distance between that point and that line, 3 root 2 units. That's a pretty complex process, but again, you have pause, you have rewind, you can go back, you can take notes on this. Please take advantage of that as we're working through things, and we'll see you in class.